Yo, what is up guys? So today I want to bring you guys another video about sorting algorithms. So today I want to talk a little bit about merge sort and how it works. So starting off about its time complexity. So on the best, average and worst cases, it's n log of n. And about its space complexity, as it's a recursive algorithm and it's not in place, meaning that when you're sorting an array using merge sort, you're going to create copies of arrays and that's going to need extra memory space. We're going to consider it being the sum of the recursion call stack plus the sum of the extra space you need to store the copy of the arrays, so O of n plus O log of n, and this will return O of n. So it uses more memory than quicksort because of the idea of creating copies of the arrays, and that's why it's mostly widely used when it comes to sorting linked lists, where you don't have to create a copy of the linked list. You just have to switch the pointers or change the data inside the pointers to actually sort the array in the order you would like. So in this video, we're going to talk about how to use merge sort to sort arrays, not linked lists, but probably in the future I'll bring you a video on how to use merge sort to actually sort a linked list. So talking about a little bit how the algorithm works. So this merge sort is a divide and conquer algorithm, and what I mean by that is that we're going to divide the original array into chunks until we cannot further divide the elements in the array. And then we're going to merge it back in a sorted format. So for that, we're going to use a merge function that we're going to talk a little bit about in the end of the explanation. And here's the original array we're going to sort throughout this example. It's the same array we used in the quicksort example. So what we're going to do is we're going to get an array. We're going to divide into two, and if there is an odd number of elements, we're just going to select either the left side or the right side to have the extra element. In this case, I've selected the right subarray to have one extra element. It doesn't matter. And now we're going to recursively call merge sort in the left and right subarrays until we cannot further divide it. So now we're going to call the merge sort on the left subarray, 8 and 3. We divide it into two arrays, or into two subarrays, and now we have two subarrays that have only one element, and therefore we cannot divide them anymore. So all there's left to do is to merge them back together in a sorted format. That's where we're going to use a function called merge sort, and we'll explain a little bit how it works at the end of the explanation, as I stated before. But for now, just know that we're gonna insert the elements back into an array that has the length that is the sum of the two arrays we're merging. So we have one array with one element, so length 1, and another array with one element, so length 1. So the merged array has length 2, and it's sorted 3, 8. Now let's do the same thing on the right subarray of the original array. Let's divide it into two. So we have the left subarray being number 1 and the right subarray containing two elements, 0 and 4. And as we cannot divide 1 any further, let's apply merge sort on the right subarray that still has two elements and divide it into 0 and 4. And now that we cannot divide any further, we're just gonna merge them back in a sorted format. In this case, it's already sorted, so just gonna bring them back together as 0 and 4. And then we're gonna merge it back together with the number 1 that has been left behind from the previous iteration. Now we're just gonna merge this number 1 with 0 and 4, so two arrays, and we're going to merge them in a sorted format. So now we're merging two arrays, and the total length is 3, so that's why the merged array here has length 3. And the result is 0, 1, 4. And going back once again to the previous iteration, we have the left subarray of the original array sorted, 3 and 8, and the right subarray of the original array sorted, 0, 1, and 4. And now we're going to merge them into the original array in a sorted format, so it will return us 0, 1, 3, 4, and 8. So this is how the merge sort will work to sort the arrays. And here is the sorted array. But let's talk a little bit about the merge function that is the core of how this algorithm works. And in order for us to create this function will receive two arguments, or three arguments, three arrays, and another three arguments in this case, because we need to get their sizes. And we have to iterate over the two arrays we want to merge together and compare each element of these two arrays, so we can get which one is the biggest element and place it in the correct position on the third array, and this will result in the third array being sorted. So as I stated before, I'm going to show the example here. The length of the third array has to be the length, the sum of the lengths of the two first arrays we're merging. So in this case, we're merging back array number 1, 2 elements, and array number 2 with 3 elements. So array 3 must have 5 elements. And in this case, we're going to iterate through each array, array number 1, array number 2, and array number 3, and we're going to compare array number 1 and number 2 elements. And you can compare them in any order. You could go from the start to finish, but I'm going to choose to go from the finish to the start. The only thing that will change is how you're going to compare the elements. If you start at the beginning of each array, you're going to have to compare which one is the smallest element, so you insert at the first index of array number 3 the smallest element, and so forth and so on. But I'm going to start at the end of the arrays here, and now we're going to compare which one has the biggest element at the end, so we can insert at array number 3 the biggest element at the last index. So we compare, is 8 greater than 4, or is 4 greater than 8? In this case, 8 is greater than 4, so we will select the array number 1. And once we select array number 1, we're going to copy the greatest element to the purple pointer, so the last index, and we're going to decrement both the purple index and the index of the array that we've picked the element from. And so now we're going to compare again the yellow and the pink pointers. So is 3 greater than 4? No, in this case 4 is greater than 3. So 4 is going to get copied here to the second to last position in array number 3. And we're going to decrement the pink pointer and the purple pointer. And we keep doing that. So we ask again, is 3 greater than 1? Yes, so we're going to pick 3 and place 3 here at the purple pointer and decrement the yellow and the purple. And now that one of the arrays has we have used all the elements of one of the arrays, the only thing that is left to do is to copy the elements from the remaining array into the remaining spaces of the third array. And the only thing we have to do is copy 1 and then copy 0, and we're done. So we have used all the elements from both arrays, and our resulting array is sorted. And this algorithm is applied, this merge sort is applied since we've reached the divisions where we only had 2 elements. So we are breaking down this big array into smaller chunks, and once we reach chunks that cannot be divisible anymore, they cannot get broken down any further, we're going to merge them back together in a sorted format using that algorithm. So in here we're comparing which one is greater. Is 8 greater than 3? Yes, so then we're inserting 8 at the last index, and now that we don't have any more elements from this left subarray, we're going to copy all the elements from the right subarray, therefore we insert 3 here, and we do the same thing here. So we break down these two. We ask which one is bigger in case 4. This 4 is the biggest element. So we insert 4 here, and then we insert 0. And here we ask the same questions. So which one is the biggest element? Is 1 or 4? 4. So we insert 4 and decrement the pink pointer here. And then we ask the question, is 1 greater than 0 or 0 greater than 1? In this case, 1 is greater, so insert 1 here and decrement the pointer. So now all the elements from the left subarray has been used. We just copy 0 here, and we do this again. This is the example we've just shown here. About how we're gonna use the merge function to restore the original array. So that's all. So I'm just gonna get to the end of the presentation here. So as I stated before, this sequence of merge events, they start when we only have one element in each subarray, and they keep getting returned and merging the previous arrays until we finally reach the merge sort on the original array, and we have the array fully sorted. So now let's move on to the code implementation of merge sort. So let's hop onto the file here. I've created a file called MergeSort. So let's hop onto MergeSort here real quick. And let's start by including the stdio as always, so we can have some print statements. And also let's create a definition here called number of elements of x, and x will be an array. And the idea of this macro is to calculate the size or the number of elements inside an array. And to do that, we calculate the size of the array divided by the size of the first element in the array, size of x0. So this is the size of the array in bytes divided by the size of bytes of the first element in the array. This will give us the number of elements inside that array. That will be very useful for us. So creating the main function here, returning 0. And let's create some print statements here so we can visualize what we're doing here. And the first thing I want to print are the original arrays. So let's say here original arrays, and let's create some arrays here. Array number 1 will be the same as the video, or if I remember properly, let me check here. This will be 0, 1, 3, 4, and 8. So 0, 1, oh, this is already sorted, right? So let me grab from the beginning of the video. So this is A3, 104. So A3, 1, 0, and 4. And the second array, I'm gonna get it from the top of my head. I don't know, 5 minus 8, 7, 2, 11, 12, 9, 3, 6, and 35. And let's have an array that is already sorted. So let's choose here 2, 3, 4, 5. And let's also choose an array that has only one element, 337. And from here, let's create a print function called print array, so we can print the arrays. And this function will receive the array and the size of the array, and the size is the number of elements inside the array. And as we're gonna do this for 4 arrays, let's copy and paste it 3 times. So this is array number 2, 3, and 4. And this is not x, sorry, this is array 2, array 3, and array number 4. And down here, we're gonna create the declaration or the definition of the print array function. Print array. Let me get the screen a little bit more visible here. So here we're gonna receive an integer array and a variable size. First thing I want to do is to print the array in a specific format. So I'll first print an opening bracket, and I'm gonna loop through the array for int I equals 0, while I is less than size minus 1, because I want to loop until I reach the second to last element. I want to print the last element in a separate line. And in here, let's open here and create in here the printing format we want to print the element. In this case, it's going to be the element, a comma, and a space, and in here the array of the index. And at the end, I want to print the last element in its separate line, and this will be the number, closing bracket, in a break line, and this will be array of size minus 1. Again, let's just test if this is working. So let's go back here, compile it, GCC, MergeSort. I forgot to create the function declaration. So let's hop onto here, onto the print array, and copy this, create the function declaration, clear this, recompile it, and run it. So let's get MergeSort. And yeah, so the printing function is working. And now let's hop onto the back onto the file again. Let me just zoom out a little bit. Hop onto the file. And now let's create the MergeSort function. So let's hop onto line 17 here. And first, let's copy this so we can create the function declaration. And the reason why I'm going to copy this is because the function declaration of the MergeSort will be the same as the print array. So we're just going to copy this and substitute the values here that are print array for MergeSort. So this is our new function called MergeSort. And after we merge, I want to print the values that have been sorted. So this will be sorted arrays. And over here, I will just paste again the print statements so we can visualize it better. So let's save the file and let's implement the MergeSort function. So this is void MergeSort that will have an integer array and an integer size. And in here, if you remember, we're just going to call this until we reach one single element inside the array. And once we reach this element, we have to return it. So if the size of our array is less than or equal to 1, we simply return the function. So this is our stopping point. Else, we're going to break it down even further. If the array we're receiving here by the function has at least 2 elements, we're going to break it down. So we're going to create a variable called mid, and this will be size over 2. And if you recall from our example had 5 elements. So 5 divided by 2 is 2.5. This will get rounded down to 2. So this will have number 2. And then we're going to create the size, left size, a variable called left size, for the size of our left subarray. And this will be equal to mid because we want the left subarray to have less elements than the right subarray. The order doesn't matter, but this is what we have established on the example. And the right size will be equal to size minus mid. So the left size will have 2, size 2, and the right size will have size 3 because it's 5 minus 2. Okay. So now let's create the variables that will hold these values. So the arrays that will hold these values. So this will be the left array, and this will be of size left size. And let's create the right array, and this will be of size right size. And we have now to copy the values from the original array we received from MergeSort to the respective positions inside the left array and the right array. You can do it within the function, but I'm going to create a function called fillArray. And in this function, I'm going to pass the original array I'm going to copy values from, the initial index I'm going to start copying values from, and to which array I'm going to copy values to. So this will be the left array, and the size of the array I'm copying values to. So this will be left size. And I'm going to do the same thing to the right subarray. So let's substitute here everything that is left to right. And now let's create the function called fillArray. So void fillArray. This will receive the original array that I'll call MArray. So this M stands for main array. So this is the main array, and this has the original index we want to start from, copying from this array, and we're going to receive the subarray. So S array. S stands for subarray, and int s size for subsize, or the size of the subarray. And all we have to do is copy the values from main array into the subarray starting from the main index. So for int I equals 0, while I is less than s size, I want to increase I and copy the values into our S array at index I, and this will be equal to our main array at index main index, and we have to increment the main index so we can copy the values properly. And let's just check if the arguments here are correct. So every time we want to start copying values into the left array, we have to start from the 0th index. So 0 here is correct. But when we want to start copying the values into our right array, we have to start index at mid, because if you take a look at our example, we have 5 elements in total, 2 on the left side and 3 at the right side. But the indexes go from 0 to 4 in a 5-element array. So in the left side, we're going to get starting at index 0 and going up to index 1, because the size is 2. So we'll copy 0 and 1. And at our right array, we're going to start at index 2 and go up to index 4. So index 2, 3, and 4. So therefore, we will copy 3 elements inside our right subarray. So now that we have our fillArray function correct, now we have to call MergeSort on our left and right subarrays, and this will be the left array and has a size of left size, and we have to call MergeSort on our right subarray. So this is right array and size of right size. And once we have called all these values and we have gone all the way down up to where we cannot break it down further, we're going to return, and we're going to start merging them back with the merge function we're going to create right now. And this will merge these arrays in a sorted order, and will return us the original. Eventually we'll return the original array in a sorted order. So let's call merge. Merge will receive the original array, the size of the original array, the left array, the size of the left array, so left size, the right array, and the size of the right array, so right size. And let's create here the merge function. So void merge, and create the arguments here. So it will receive the original array, an integer size for the size of the original array, an integer left array, and an integer left size for the size of the left array, an integer right array, and an integer right size for the size of the right array. Now, if you recall from the slides, all we have to do here is compare each element on the left to each element on the right until one of them runs out of elements, and we start just pumping the rest of the elements from the remaining array into the third array. So in here, what we have to do is compare. So we have first to create the pointers. So let's create the pointers here. The pointer to the left subarray, I'll call left, and this will start at the last index of the subarray. So this will be left size minus 1. And same thing for the right pointer. I'll create a right pointer called right, and this will start at the last index of the right subarray. So this will be right size minus 1. And we also need a pointer for our original array, or the merged array. that we'll call original, and this will be the size minus 1. So this is the last index of our element of our merged array. And now we have to keep comparing each element from the left to the right to see which one is greater to copy to the last index here. And this will only happen, this comparison will only happen while the left subarray and the right subarray have elements. So while left is greater than or equal to 0 and right is greater than or equal to 0. And within this function, we're going to check if the left or the left array of left is greater than the right array of right. So this if statement essentially is comparing the number at the current index on left to the number of current index on right. So in this example here, we're comparing the 8 to 4, and we're checking if the left subarray has a value greater than the right subarray. If it is true, we're going to copy the value from the left subarray into the original array. So the original array at the current index of the original array, will be equal to the left array at the left index. And we have to decrement the pointers now. So we decrement the left subarray because it's the subarray we picked an element from, and we have to decrement the original array pointer as well. So let's decrement left in 1 unit and decrement original in 1 unit. And otherwise, it means that our right subarray has a greater element at that point in time, and we have to copy to the original array the right element. So right array on right. And we have to decrement the right pointer and the original pointer. And once we break out of this while, it means that we have found one of these two subarrays has reached the end, meaning that we have used all the elements from one of these two subarrays, I don't know which, and because of that we have to create 2 whiles to check if either the left subarray or the right subarray still have any elements left, and if they do, we just copy the values into the original subarray. So while the left is greater than or equal to 0, we're just going to copy all the values inside our original array. So array original will be equal to left array of left. We decrement left and decrement original. And we do the same thing for the right subarray. So in this case here, right is greater than or equal to 0. And in here, copy the values into the original array. Right array, right minus minus, and original minus minus. And that's it for the merge function. That's it for the fill array function. Now that we have finished the coding part, let's test. But before we test, let's create the function declarations for each of these functions. And copy this here. Let's get merge function as well. Get this function declaration. And the last function we have to create the declaration is for the fill array function. At here, right here, let's copy this, paste it, and fix here the end of line. So let's check if there are no mistakes in our code. So let's compile this. We have found a mistake here, typo, I guess. Right array, right size, and m index. So sorry, it's m index. So let's first fix that typo. It's m index. So let's search for m index. It's not m index, it's m index. And the other error, let's compile it, check it. The right size undeclared, first using function at line 94. So let's get back here at line 94. Right size. Haven't I created the right size? Int right size. Oh, sorry. It's a typo here. It's right array. Or no, wait. Is it? Right size. Right array. No, it is correct. What is wrong? Right size. Error. Right size undeclared. First using this function. Did you mean right size? I don't get it. Okay, the H is in the wrong position, so that's it. we have somewhere here, I don't know where, but let's rewrite this. So right array and right size. I guess, does this fix the problem? Oh yes, it does. So now let's test it. And as you can see, after fixing some typos, we have reached our sorted arrays. So even though they're sorted, there's a way we can check if the way we are executing the steps makes sense for us to actually, if we're actually using the MergeSort algorithm. So to do so, let's just print. Let's create some print statements here, just for sake of demonstration, because this code is correct, this code works, but I want to print here the elements. So let's print here the sequence of elements, and this will be the original array. So original array, and after that I want to print the left array and the right array as well. The right array as well. And let's print array. And here will be the array and size. And over here we can also get the left array and left size. Same here for right array and right size. And we're good to go. And after that I want to print the merged array. So this will be the merged array. And in here we can check print array, and size. So if we get back here and we clear this, we compile it and run, print array. Oh, sorry. Let me get back here and fix this typo. The function is print array. Sorry, it's not print array. Array in here, array and array. So this is an easy way to see what the code is doing. So if you come back here at the top, these are the original arrays, and we're doing them in order. So the first time we enter MergeSort, we call this MergeSort. This is the original array, so the whole array. When we break down into two subarrays, this will be the left subarray and this will be the right subarray, as we've seen in the example. So if we come back here and we compare it, we're breaking down this into left 8 and 3 and right 104. So exactly what we're doing. And then we're going to break down the left subarray 8 and 3 into 8 and 3, like we're doing here. So here it is. And after that, we're going to merge them back together as 3 and 8. So that's what we're doing here. 8 and 3 merged back into 3 and 8. And then we're going to move on to breaking down the 104 into left 1 and right 0 and 4. So 104 into left 1 and right 0 and 4. And we're going to break down even further the right subarray 04 into 04 and merge it back into 04. So that's what we're doing here. And then we're going to merge it with the ones that has been left, and this will become 0, 1, and 4. So if you take a look here, this will become 0, 1, and 4 because we've merged 04 with the one that has been left up the top. And next is we're just going to merge 3 and 8 with 0, 1, and 4. So this will return the original array 0, 1, 3, 4, 8. So 0, 1, 3, 4, 8. So this 0, 1, and 4 is getting merged with this 3, 8 at the top of the stack call, and this gives us back the original sorted array. So 0, 1, 3, 4, 8 as expected here. So this last step was just to demonstrate that we're actually going through all the steps we've shown here on the slides, and this is what's actually happened under the hood. So you can get and grasp a better understanding of what's going on in the algorithm. So the same thing happens for each and every other array that we have inserted here, but the steps will be longer because the second array is quite larger. But at the end, you can see the sorted arrays here, as was shown previously. So they're all in the correct ascending order because we've established that we want to sort in ascending order. And the already sorted array kept its order unchanged, and with only one element, we just returned this array, and everything works as expected. So this is basically MergeSort. It's a little bit of a mess to implement without having something to reference, like a drawing on a board or slides, or you actually having a pen and paper and drawing it, because you might get lost during the implementation via pure code. But that's why it's always good to have something like this, a material of reference where you can check if the steps are being correctly generated, and you can easily transfer it back into code once you have the prototype on your paper sheet or something like that. So this is MergeSort. Thanks again for watching. If you have any questions, post in comments down below, and I'll be bringing more videos about sorting algorithms, data structures, and coding in general in the future. Thanks for watching again, and peace.